Good day, I'm Brian Farrell, and welcome to session on WAN Technologies Part 1. Today I'm going to be talking about the public switched telephone network, then I'm going to move on to broadband cable, and I'm going to conclude with a brief section on fiber optics. And with that, let's go ahead and begin this session. Of course, we begin with the public switched telephone network. Before I begin with the public switched telephone network, let's talk about what makes a WAN as opposed to a LAN. Well, as a general rule, if you own and control the line that the data is using to get from one place to another, you are not using a wide area network or WAN technology. On the other hand, if you are using a form of transmission that you don't own, as in you're leasing a line or you're paying for the use of it, then you are likely using WAN technology. One of the most common physical infrastructures used in WAN technology is the public switched telephone network, the PSTN, due to its widespread availability. Just about everybody has a telephone line being run to their house or to their building. An older technology, but still somewhat valid today for WAN technology, is dial-up. Now, dial-up utilizes the PSTN to transmit network traffic as an analog signal. Dial-up does require an analog modem to format the network traffic correctly so it can be transmitted. Your maximum theoretical speed on dial-up is 56 kilobits per second. It's not very fast. Then there's ISDN, Integrated Service Digital Network. ISDN is a digital point-to-point WAN technology that utilizes the PSTN. It's a completely digital service. It requires the use of a terminal adapter, or TA, to make the connection to the end nodes. This TA is often called a digital modem, but it's not. It's a terminal adapter. ISDN can use a primary rate interface, or PRI. Now, the PRI is composed of 23 64 kilobit per second B channels and one 64 kilobit per second D channel. That D channel is used for call setup and link management. A PRI can achieve 1.544 megabits per second speed, and that is commonly referred to as a T1 leased line. The most commonly implemented form of an ISDN, though, is the BRI, the basic rate interface. It uses only 2 B channels and 1 D channel, and the BRI can achieve speeds of up to 128 kilobits per second. Now, ISDN is not as capable as a digital subscriber line, or DSL, but it can often be implemented where DSL cannot be installed. Speaking about DSL, let's move on to it. XDSL is the term for generic DSL. DSL is a digital WAN technology that utilizes the PSTN. DSL does require the use of a digital modem. It uses a dedicated digital line between the endpoint and a Class 5 central office, or CO. Now, in order for the most basic forms of DSL to be installed, you have to be within 18,000 feet of the CO. DSL is capable of carrying voice and data. When it does carry both, filters are put in place in order for the voice signal to come through without any interference. Now let's move on to the different types of DSL. And first up is symmetric DSL, or SDSL. Symmetric DSL is synchronous in nature. That means that the upload and download speeds are the same. SDSL does not carry voice communication. So if you need voice service, an additional line is going to be needed. SDSL is used by businesses that don't quite need the performance of a T1 leased line, but they do require the symmetrical upload and download speeds. More common than SDSL is ADSL, or asymmetric DSL. It's asynchronous in nature. That means that the upload speed is slower than the download speed. ADSL can carry data and voice. Common upload speeds for ADSL are 768 kilobits per second with download speeds of up to 9 megabits per second. It is the most common implementation of DSL in the small office, home office environment. Last up for DSL is VDSL, or Very High Bitrate DSL. It's asynchronous in nature as well. It's used when high-quality video and voice over IP is necessary. VDSL is commonly limited to download speeds of 52 megabits per second with an upload speed of 12 megabits per second. That's a whole lot faster than ADSL. But VDSL is only possible when you're located within 4,000 feet of a central office. There is an exception to what I just told you though. The current standards do allow for up to 100 megabits per second speed over the PSTN using VDSL, but in order to achieve that, you must be within 300 meters of the central office. Now that the PSTN is out of the way, let's move on to broadband cable. Broadband cable is coaxial cable networking. It's a broadband connection to a location delivered by the cable company. Broadband cable can deliver voice, data, and television all through the same connection. And the way it works is the digital signal is delivered to the head-end. This is where all the cable signals are received. The signal is then processed and formatted and then transmitted to the distribution network. The distribution network is a smaller service area served by the cable company. The distribution network architecture can be composed of fiber optic cabling or coaxial cabling and or a hybrid fiber coaxial cabling or HFC. Unlike DSL, the bandwidth of the distribution network is shared by all of those who connect to it. This can lead to increased latency and congestion during busy times. The final distribution to the premise is usually through a coaxial cable. The other thing that you need to know about broadband cable is that all cable modems and similar devices must measure up to the ISP's required data over cable service interface specification or DOCSIS specification. If it doesn't measure up, you're not going to achieve the speeds that you expect. Now let's conclude with fiber. Fiber optic networking is using light to transmit data and voice. This allows for more bandwidth over greater distances. Fiber optic networking is more expensive to install, but is also less susceptible to line noise. The fiber synchronous data transmission standard in the United States is called the Synchronous Optical Network, or SONET standard. The international standard is called the Synchronous Digital Hierarchy, or SDH. Both SONET and SDH define the base rates of transmission over fiber optic cabling, which are known as optical carrier levels. Dense wavelength division multiplexing is a method of multiplexing several optical carrier levels together, up to 32 of them, into a single fiber optic cable, effectively increasing the bandwidth of that single optical fiber. Instead of DWDM, you could use CWDM, coarse wavelength division multiplexing. It's similar to DWDM, but it only allows for up to 8 channels on a single fiber. When fiber optic is delivered to the premise, it's usually delivered over a passive optical network, or PON. A PON is a point-to-multipoint technology that uses a single optical fiber that's used to connect multiple locations to the internet. The passive optical network uses unpowered optical splitters. Now that concludes this session on WAN Technologies Part 1. I talked about the public switched telephone network, Then we moved on to broadband, and I briefly